Hey everyone, welcome back to the channel. In today's video, we're diving into the powerful XLOOKUP function. The XLOOKUP function can search in any direction, left, right, above, or below. It's a more advanced alternative to lookup, VLOOKUP, and HLOOKUP, and it's available in Excel 365 and Excel 2021. Let's talk about the syntax. Don't worry, it's simpler than it looks. First, we have the lookup value. This is the value you're trying to find. It can be a number, some text, or a reference to a cell. Second is the lookup array. This is the range where Excel will search for the lookup value. Third, we have the return array. This is the range where Excel will pull the corresponding value once it finds a match. Fourth is the if not found argument. This one's optional, but very useful. If Excel doesn't find a match, instead of showing an error like NA, you can specify a custom message like not found. It keeps things cleaner and more user-friendly. Fifth, we have match mode, which is also optional. This tells Excel how it should match the lookup value. By default, XLOOKUP looks for an exact match, and this is represented by 0. If you want an approximate match, you can set it to -1 for an exact match or the next smaller value, or to 1 for an exact match or the next larger value. There's even an option to use wildcards with 2. And finally, there's search mode. This argument tells Excel the order to search in. The default setting is 1, meaning Excel searches from top to bottom or left to right. The 2 and -2 settings are used to perform a binary search, which is faster but requires your data to be sorted either in ascending or descending order. With this function, you can search for a value in one range and easily retrieve a corresponding value from another range, all while enjoying greater flexibility and fewer restrictions. Let's take a look at a simple example to see XLOOKUP in action. Here, we have a table listing students and their scores. Now, let's find Alice Johnson's score. We'll use the XLOOKUP formula in the cell where we want the result. As you can see, when we enter the formula, Excel returns 85. Easy, right? Now, let's look up David Brown's score. Just like that, Excel returns 88, which is exactly what we expected. Next, let's search for a student name that isn't in our table. When I try to look up ABC, Excel gives us the NA error. This means the name wasn't found in the lookup array. Now, it's worth noting that, unlike other lookup functions like VLOOKUP, the XLOOKUP function defaults to an exact match. So, if the exact value isn't found, you'll get that NA error, unless you change the match mode. But here's where XLOOKUP shines even more. It includes an optional argument to handle cases where no match is found. Instead of seeing that frustrating NA error, you can display a custom message. For instance, if I search for ABC, which isn't in our table, I can add not found as the fourth parameter in the formula. Now, Excel will return not found instead of the error. The previous example demonstrated a left-to-right lookup, where we search for a student's score based on their name. Now, let's flip the direction and perform a right-to-left lookup. This time, we'll use the XLOOKUP function to find a student's name based on their score. In this example, 92 is the score we're looking for in the range B2 to B15, and we want to return the corresponding student name from the range A2 to A15. The formula will return Bob Smith. Now, let's try finding another student's name based on a score that doesn't exist in the score range. When this happens, the result will be NA error. This is because XLOOKUP, by default, looks for an exact match, and NA indicates that no exact match was found. To handle this, we can use the fourth argument, if not found, to customize the error message. Instead of showing NA, we can display something like not found. This is a great feature allowing you to customize error handling or even perform alternative actions when a lookup fails. Now, let's take things a step further. One of the key advantages of XLOOKUP over traditional VLOOKUP and HLOOKUP is its ability to search both vertically and horizontally. To demonstrate this, we'll switch to a horizontal table layout. We'll use the same data, but this time arranged in columns. The students' names are now in row 1, spread across columns B to O in the range B1 to O1, while their scores are in row 2, spread across the same columns in the range B2 to O2. In this example, we're looking up the score for Bob Smith in row 1 and returning the corresponding score from row 2. As you can see, the formula returns 92, which is Bob Smith's score, demonstrating XLOOKUP's versatility in handling horizontal lookups. Similarly, you can find a student's name based on a given score. To do this, we use the formula as shown on the screen. In this case, the formula searches for the score 92 in row 2 and returns the corresponding student's name from row 1. The result is Bob Smith, the student with a score of 92. Now, let's dive into XLOOKUP's fifth argument, match mode. We'll demonstrate this by generating student grades. The match mode argument can have one of four values: 0, -1, 1, or 2. 0 means exact match. -1 means exact match, or the next smaller value. 1 means exact match, or the next larger value. 2 allows matching wildcard characters like asterisk and question mark. This argument is optional, so if you don't provide a value, XLOOKUP defaults to 0, which looks for an exact match. All of our previous examples have used this default exact match setting. To demonstrate how the match mode argument works, we'll use the value 1, which finds the next larger value if the exact lookup value isn't available in the lookup table. In the lookup table, we've broken down the scores into 100, 90, 80, 70, 60, and 50 with their corresponding grades: A, B, C, D, E, and F. The logic here is simple. If a user's score is between 91 and 100, they get A. If it's between 81 and 90, they get B, and so on. Scores 50 or below will get F. To generate the grade for the first student, write this formula in cell C2, as shown on the screen. The formula generates B for the score of 85, which is exactly what we were expecting. Let's break this down. The first argument, B2, is the user's score that we want to match. The second argument is the range for our breakpoints. The third argument is the range for the grades we want to return. Notice I've used the dollar signs to lock the ranges, so that when we copy this formula down, these ranges remain fixed. We haven't used the fourth argument, if not found, because it's not needed in this case. Since it's optional, we can skip it. To do so, simply leave it blank by adding a comma and moving on to the next argument. The value 1 in the fifth argument tells XLOOKUP to find the next larger value if an exact match isn't found. For example, if a student has a score of 85, XLOOKUP will search the lookup table for a match. Since there's no exact match for 85, the function will find the next larger value, which is 90, associated with the grade B. So, for a score of 85, the function will return B. The same logic applies to a score of 92. Since it's not available in the lookup table, XLOOKUP will find the next larger value, which is 100. As 100 corresponds to grade A, the function will return A. Here's another key difference between XLOOKUP and the traditional lookup or VLOOKUP functions. XLOOKUP doesn't require the data to be sorted in ascending order when performing an approximate match. It can find the correct match regardless of the order in the lookup table. As you can see on the screen, I've rearranged the breakpoints and their corresponding grades randomly, but the XLOOKUP formulas in the grades column still return the correct grades. Now, let's explore another option, search mode with the value -1, which tells XLOOKUP to search for the next smaller value in the lookup range if an exact match isn't found. We'll demonstrate this by calculating the discount for each customer based on their spending. The more they spend, the higher the discount percentage they receive. If a customer spends a minimum of $200, they receive a 5% discount. For a minimum of $500, the discount increases to 10%, and for customers spending $1,000 or more, the discount is 20%. I've created a lookup table with these thresholds. The spend thresholds are in H3 to H5, and the corresponding discounts are in I3 to I5. To calculate the discount, we've used this formula. Let's break down this formula. B2 is the lookup value, which is the customer spending in this case. H3, H5 is the lookup array, containing the spend thresholds. I3, I5 is the return array, which holds the corresponding discount percentages. The fourth argument is left blank, meaning we're not using the optional if not found argument. The fifth argument, -1, in match mode, tells XLOOKUP to find an exact match or, if that isn't available, the next smaller value. In our case, this is perfect because we want to apply the highest possible discount without exceeding the customer spending. For example, if a customer spends $312, there's no exact match for $312 in the lookup table. But because we've used -1, XLOOKUP will find the next smaller value, which is $200, and apply the 5% discount. Now, let's double-click the fill handle or drag it down to calculate the discount for all customers. But, as you can see, the formula generates a value error. Let's edit our formula in cell C2. The issue is that we haven't used the dollar sign in the ranges for the lookup array and the return array, which is why we're seeing the error. To fix this, we need to use absolute references by adding the dollar sign to both ranges, so they continue to point to the correct lookup table as we copy the formula down. Notice that our formula gives NA error if the spending is less than $200. This happens because XLOOKUP can't find a match for values below our lowest threshold, which is $200 in the lookup table. Since there's no lower value to return, it results in an error. To fix this, we can use the if not found argument to provide a custom message or value when no match is found. For example, we could modify the formula like shown on the screen. This way, if the spending is less than $200, the formula will return 0 instead of giving an error. You might also notice that the formula returns values like 0.05, 0.1, and 0.2 instead of showing as percentages. This happens because Excel interprets the numbers as decimals. To fix this, simply format the cells as percentages. Select the discount column, right-click, choose Format Cells, and then select Percentage. Now, the results will display correctly as 5%, 10%, and 20%. Next, let's talk about wildcard characters in this lookup function. Wildcards allow you to perform flexible lookups when you're not sure of the exact value. XLOOKUP supports two types of wildcards: the asterisk, which represents any number of characters, and the question mark, which represents a single character. For example, if you're looking for a customer whose name starts with B, but you don't remember the full name, you could use this formula. Here, the asterisk after the B tells Excel to look for any name starting with B, no matter what follows. So, if there's a customer named Bob or Bush, the formula will return their complete name. The asterisk can replace any combination of characters. Let's take another example. This time we'll use the question mark. Say you're looking for a name that has exactly 3 characters, starts with an E, and ends with an A. You can use the question mark as a placeholder for any single character in the middle. In this case, the E and A are fixed, while the question mark represents any single character between them. So, if a name like Eva exists in the range, it will be returned by the formula. This wildcard technique is very useful when you know part of the data but need to fill in the gaps. Now, let's discuss the search mode argument in XLOOKUP, which controls the search order in your data. There are 4 options for search mode. The first option is 1, which is the default setting that searches from top to bottom or left to right. The second option, -1, searches in reverse order, from bottom to top or right to left. The third option, 2, performs a binary search on data sorted in ascending order. Finally, the fourth option, -2, performs a binary search on data sorted in descending order. We have 2 customers with the same name, Eva White, in our table. One Eva White is in cell A6 with a spending of $1,820 in B6, and the second Eva White is in cell A16 with a spending of $392 in B16. By default, XLOOKUP searches from the top of the list. So, if we look for Eva White without specifying a search mode, it will return the data for the first Eva White it finds, which is the one in A6 with $1,820 spending. But what if we want to find the second Eva White, the one in A16 with $392? This is where the search mode argument becomes useful. To search from the bottom to the top, we'll use -1 in the search mode argument. In this formula, the -1 tells Excel to search in reverse order, starting from the bottom. This way, the formula will return the data for the second Eva White with a spending of $392 in B16. So, search mode gives you the flexibility to control the direction of your search, which is especially useful when you have duplicate names or need to find the most recent entry in your data. Thank you for watching. Please share this video and don't forget to like, subscribe, and hit the notification bell for more Excel tips and tutorials. Your support helps us create more valuable content. See you in the next video.